This is 4.5C, page 404, solving logarithmic equations. Now, one of the things that you'll notice here is I have a logarithm on one side and not a logarithm on the other side. And I can't just stick another logarithm on there. So what I'm going to try to do is, when I've got it like this, is I'm going to convert to exponential form. So if I can convert this whole thing to exponential form, then I can go ahead and solve it. So this is stuff that we've done before. So 3 to the negative 2 equals x. So 1 over 3 squared equals x. Therefore 1/9 equals x. And I'm done. Okay? So let's try another one so that you get the hang of what's going on, because obviously that we start out with an easy one and they get a little more challenging. So we've got log base 10 of x plus log base 10, but I'm going to have x plus 3 here. And I'm going to say that that is equal to 1. Okay, so because my bases are the same here and here, I can bring these two together and multiply. Okay, so remember this is back a while. So I'm taking the logarithm of that, and that equals 1. Okay, so what did that do? It got me from 2 different logarithms to 1 logarithm. And when I have 1 logarithm, then I can switch to exponential form. And when I switch this to exponential form, it gives me 10 to the first power equals x times x plus 3. Then it makes it real easy just to do the math. X squared plus 3x. Okay, then I write x squared plus 3x minus 10 equals 0. And I can do that. That isn't a problem. I can break that down into 2 binomials because I've got an x and a 5 and a 2 and a negative, oops, a positive and a negative. So my x is going to be negative 5, and it's also going to be 2. And this is one of the situations that you run into, is you're going to have to check these. Because when we put a negative 5, clear back here at the very beginning, if we put a negative 5 here and a negative 5 here, and you solve it, you're not going to get 1. But it will work with 2. And one of the things that you're going to find out is you cannot get a negative answer. Okay, if you, like this one, we got x is 2 and x is negative 5. X is negative 5 does not work. You cannot get a negative answer because they do not have real number logarithms. So the only one that's going to work is 2. Okay, this is very similar to the one we did before. This is example 8, page number 406 in the middle. And again, we are going to try to get my logarithms so that they're just 1 logarithm. So because of this minus sign, I'm going to divide. So I'm going to write this as log base 3 of 2x minus 1. And I'm going to put that over x minus 4 equals 2. This is why you learned how to do that. So now I can make this into logarithmic form. So 3 squared equals 2x minus 1 over x minus 4. Or this is not 3 squared, we'll write it as 9. Okay, and then we can just cross multiply. We can multiply this and then this by, well, 9 over 1. So 2x minus 1 equals 9 times x minus 4, which gives me okay, and I just keep going from there. I add 1 to both sides, and that goes away. I subtract 9 from here, and I get negative 7x equals negative 35. Therefore, my x is 5, and it works just fine. A final example is on top of page 407. This is example 9, and we're going to do a natural logarithm with 4x plus 6, and we're going to subtract ln of x plus 5, and that will equal ln of x. Okay, so again, we're going to put these together. So ln of 4x plus 6, and we're going to put that over x plus 5, and that will equal ln of x. Okay, the nice thing about it is the property of logarithmic equality says that if I have an ln and an ln, and I have this here and this here, I can just take off the ln signs. I can just take off the logarithm signs. So I can just write this as 4x plus 6 over x plus 5 and say that that equals x, and I can solve it, and I end up with an answer of x equals -3 and x equals 2. And I know that when I get -3 and 2, -3 does not work because it does not give me a real number logarithm. Okay, so just a reminder how I got from there to here. If you jump back to page number, let's see, where is it? I guess the closest thing we're going to get is page number 399, bottom of the page, where I had log AM equals log AN when M equals N. Okay, so this is what this was up here. My two logarithms were the same, and that is true when these two are the same. And those two are this number here after the logarithm, this number here after the logarithm, or this and this. So this can equal this because of that property of logarithmic equality. So that's how I did that. Okay, so that's it for 4.5.